Alright, finding limits numerically. We've gone over the fact of what a limit is, that it's the intended height of a function. I've talked about how there's three different ways, so let's talk about the numerical approach. This is probably the most basic and easiest approach. All it really involves is us just reading a table and using the table to see as x changes, how is the height changing, or how is the y changing. So let's give it a shot. Okay, so they give us a table here. There is a couple typos in this video. That value should be negative right there, but not these ones. They give us a table and we can see that we're getting 2.9, 2.99, 2.999, 3.01, 3.19. Obviously that doesn't need to be there. So we're looking right here, right? Here's 3. And we're asking the question, hey, what is the limit of g of x as x approaches 3, and that little negative sign means from the left. So let's do this one in red. All we're saying is, what is it approaching this way? And it looks like it's going to be approaching approximately something like negative 5 point, I don't know, we could say 0.1, approximately negative 5.01. And then we can ask the same question from the right, because that's what this little plus sign means, right? This little plus, what is it approaching from the right? Well, as we go this way, closer and closer to 3, what is the height getting closer to? Well, we can see that these are positive values, still getting really close to 5.0 something, but now it's positive, so I'm going to say approximately 5 point, and I'll still say 5.01, but positive, something like that. Okay. Well, now we're going to use this information to ask if the general limit exists. And remember, in order for the general limit to exist, the left and the right-hand limit have to be the same. Well, they look like they're the same, but one's negative, one's positive, so those are totally different values. Therefore, for the general limit, we're going to just say the limit does not exist. And that's all there is to it. Okay, let's go ahead and take a look at the next one. Alright, a couple typos on this one. I went and checked my math, and these should all actually be positive values here. Other than that, we're in good shape. We can see we have this complicated rational function here. It's not that bad. And we're asking about 2. Looks like 2 is right here. And so first we're asking about from the left. So what is it approaching from the left? As we get closer and closer to 2, right, as x gets closer and closer to 2, we could see that it's getting closer and closer to 0.333, or 1/3. So I'm going to say this looks like it's actually, we could almost say that it's equal to 1/3, because it's definitely getting close to 1/3. Alright. How about from the right? Well, as we get closer and closer to 2, it looks like it's also getting closer and closer to 1/3, right? So I'm just going to say it equals 1/3. And now we can ask for the general limit. And the general limit, if they're both approaching the same value, which in this situation they are, they're both approaching 0.3 repeating, which is 1/3, we could say that the general limit is 1/3. That's all there is to it. Now we're going to prove this analytically later, and you'll see how we can also show that this is true analytically. But for now, all we're doing is just reading the chart and seeing, hey, what's it getting really close to? Alright, let's go to the next one. Okay, here we're talking about some function h of x. We don't know what h of x is, but we do know some values for it. And we're talking about as the limit approaches 4, from the left, from the right, and then the general limit. Well, 4 seems to be about right here, so let's take a look. First from the left, that's approaching this way. Well, that looks like it's approaching negative 3 and 1/3. We could see that that's getting closer and closer to negative 3 and 1/3. Alright, how about from the right? Well, as we get closer and closer to 4, again, that decimal shouldn't be there. We see that it's getting closer and closer to negative 3 and 1/3. And so, we know it's the general limit must be, since they're the same value, negative 3 and 1/3. You could also, of course, write this as negative 3.3 repeating, but in calculus, fractions are going to serve us a lot better. Okay, that's how you find the limit numerically. I'll see you guys on the next video.